So last time we did the alternative to asking yourself what's missing in this factoring process, and you may or may not find this simpler, so feel free to either use this suggestion or not use this suggestion. But here's another way that I like to think about it. Asking what's missing is the same thing as dividing. So another way to go about it is this. If I want to know what's missing in each one of these terms, what I can do is divide each of those terms by the greatest common factor. 3y to the fourth, 3y to the fourth. And by dividing each of these terms by the greatest common factor, that will automatically take out of those terms everything that 3y to the fourth has, right? Everything that it can account for by itself. And so the only thing that's left over after we do this division is going to be exactly what's missing that separates 3y to the fourth from each of the two terms that we wanted to have over here. It also gives us an opportunity to talk about something that we didn't give a lot of airtime to earlier in Chapter 4, which is how do you divide powers of a variable? Like, what's going to happen when I divide this y to the fourth by this y to the fourth that's present here in this first term? What happens there? They cancel out. Oh, right. So Keely said two things. First of all, they cancel out. And I agree with that. But let's take that a step further. Because you also said, what's the reason that they cancel out?
Because you're subtracting.
What are we subtracting?
The y squared. The y to the fourth.
Yeah. So remember when we talked about combining exponents and doing arithmetic with exponents before, when we multiply powers of a variable together, their exponents add. And so conversely, when we divide powers of a variable by one another, their exponents subtract. So the number of powers of y that I'm going to get here is going to be the difference 4 minus 4. But 4 minus 4 is just another name for 0. And what's y to the 0 mean?
1.
It means 1. Another common mistake there is calling it 0. It's not. Having something raised to the 0 power means we're going to multiply by it no times. To multiply by something no times is the same as to multiply by 1. So y to the 0 can turn into just 1. It means that there are no factors of y at all, and therefore that whole factor just disappears. So one way to think about it was that the y to the fourths just cancel out, and that's true. But I think you get a little bit more deep understanding of why that happens by thinking of it as a process of subtracting exponents. Same thing happens in the second factor, second term over here. Y to the fourth divided by y to the fourth, y to the 4 minus 4. That's the same as y to the 0. And that's the same as not having a y there at all. Okay, so then all the dust settles, and we're left now with 9 divided by 3, which is, yeah, that's where we got the 3 from. And we're also ending up here with 3x divided by 3, and what is that? What's going to happen to simplify this term? What does 3x divided by 3 simplify to? Yeah. The 3's cancel. Again, because 3 is a common factor in both the numerator and denominator. And so the only thing that survives is x. Or if you like, x over 1. But let's just call it x. So that what I have when I finish factoring is 3y to the fourth, the greatest common factor pulled out to the front, multiplied by the cofactor 3 plus x. And you can get it by reverse thinking, but you can also get it through a process of division, the way that we just showed it up here. If that connects with you better, because it gives you kind of a recipe for how to do it, then by all means feel free to use that way. If not, then don't.